Hello everyone, and thanks for joining. In this presentation and demo, we're going to take a look at how the IBM Watson Visual Recognition service works, and we will reinforce that with a few examples. So let's start with a quick introduction of some available resources and some quick definitions. One of the pages that is important to know about is the main Watson Developer Cloud page. This provides information about different Watson services, and it also provides the SDK that you can download for your relevant runtime environment. There's also another page, which is the API Explorer for different Watson services. And as you can see, the services are categorized by language, speech, vision, and data insights. And each of these links will take you to a page where you would see detailed information about the available endpoint and the capabilities. In this scenario, we're going to look at the visual recognition service, so I'll switch over to that page. This is the API Explorer for Visual Recognition service. This is a representation of the Swagger file that defines all the endpoints and the schema for the input and output parameters. This interface also enables you to invoke the endpoint by providing values for the parameters. And as you can see, it is a good way to figure out what endpoints are available and what parameters are accepted by each endpoint, and also what sorts of values you would be expecting from that service, as it is shown here. It sort of defines the schema of your service, the input parameters, the results, and by just entering the values here, for instance, if you want to classify an image, you provide your API key at a minimum and the URL of an image, and basically hit the try out button here and you get the response back. So this is a quick way of getting an overall view of all the available endpoints and the parameters available on them. But in our scenario, in our demo, we are going to invoke these services through command line. The API reference link is also important. It describes the details of all the available endpoints, and also, depending on the kind of runtime that you're going to be using, provides details how to install the SDK. So in this case, I'm choosing Node, and through npm install and referring to the package Watson Developer Cloud, I installed the SDK, and there are examples of how to instantiate the SDK, and also what sorts of input parameters like the API key version and information that you have to provide to instantiate that SDK, and how to invoke one of those endpoints that we saw in the previous page, right? So in this case, classifier, for example, is invoked by passing in parameters, which includes the image file. There's also a ready-made demo available that shows you some of the capabilities of the out-of-the-box capabilities of the visual recognition service without the need to train the service. It already can determine a wide variety of images, what they are, what classification they belong to. There's also the main documentation page where you would be able to see information about the capabilities, some tutorials on how to invoke the endpoints to either classify an image or how to define custom classification. So this is the kinds of hands-on information that we're going to look at together. Again, an introduction, there are two terms that are quite important: classifiers and classes. Classifiers are basically a container for classes, and classes are the notion that you're trying to extract from that image. So let's say you have a number of dog images and you want to classify them under dog breeds. So the classifier will be dog breeds, and then the classes would be the breeds of those dogs. So you would have German Shepherd, for example. You would have Golden Retriever. These will be the different kinds of dog breeds that you want to classify. So those will be the classes. So in our example, we are going to use the same notion, define a classifier and the relevant classes for the classifiers. Let's look at some of the prerequisites before we can get started. First, you need to have a Bluemix ID, and by signing up for either a free account or a paid account, and after you have the Bluemix ID and log into your console, you can create a visual recognition service instance, and that service instance ultimately provides you with an API key that you would be able to use in the examples that we're going to work together. As mentioned earlier, we're going to use the command line to invoke most of our services, and to make things easier for us, we are going to set an environment variable for strings that either are private or are going to be long to include in a URL. So API key is one of those examples. We will set in our shell script on the command line, we'll set the API key value to the API key that we get generated from the service. And there are other environment variables that when we're working through our examples, you will notice that we will be using, and we'll also set them appropriately as it is required. So for example, classifier ID that we create, the custom classifier that we create for ourselves, or an image URL that we would want to classify, for instance. So we will set these as environment variables, and like any shell script will reference those by a $sign and enclosed in curly braces. Now let's take a look at how we create the visual recognition service in Bluemix. After signing up for a Bluemix account and logging into the console, just navigate to the catalog up here, and then from there navigate to the Watson area of the services, scroll down and find the visual recognition service, and by selecting that you will get a page where you would be able to provide a name for your service. Leave the service unbound because we're not going to bind it to any kind of application. And if you have a paid account, you can use the standard service, or you can use the free service. If you have a trial account, in the free version you can create one custom classifier and 250 events or images per day. So since I already have this service created, I'm not going to hit the create, but after hitting the create, you're going to get your service available. So let's go in and look at the service that I already have. So in my service, after you have created your service, you would be able to go in and select that service and look at the credentials part. So here, the second tab here says service credentials. If you go to the service credentials, and if you expand that service credentials area, you would be able to find your API key in a JSON object. Okay, so now that we have we have created our Bluemix ID and created an instance of a visual recognition service, let's go ahead and invoke the service. We'll start with the classify example. This is a endpoint, a service that you pass in the URL of an image, and then the service analyzes that based on its default classifiers, whatever is already loaded in the service, with nothing special done by us as the consumer. And it recognizes that service and returns some information about that service. So I'm going to take this URL, which belongs to a car. Let's look at what that image looks like. So this is the image of a car that we are going to pass into the classify image and see what it can make out of this image. So I'm going to copy this and go to my command line and create an environment variable called image URL, and I'm going to use the endpoint of the Watson service that I got after creating the service. And if you remember, we looked at the Swagger document and we saw all these endpoints, v3 classify or v3 classifiers. So these are the endpoints that we're going to append to the end of the URL that we have. And then we pass in a few parameters. API key is one of the required parameters, and it's already set in my command line environment to the API key that I have for my service. So you would do a similar thing, just like the image URL that we set the URL of the image to that variable. You would create an environment variable called API key, and you would set the API key value to that variable, so you can reference it here in your command without requiring to repeat that everywhere. And then the version value that is preset and provided to us through the SDK. And then the URL parameter to this HTTP endpoint where we pass in the URL of the image that we're going to ask the service to classify. And as you saw, as you can see, we have the image URL up here set to the endpoint that we want to, to the image that we want the classify service to identify. So I'm going to copy this command and go into my command line and paste it here, and let's invoke this service. As you can see, it came back with no custom classes, just because we are using the default available classifier. So from the classifiers that we have, it through the default classifier, it recognized that this belongs to a class of cars with 95.6% score, and it also provides you with a type hierarchy car. And then it also recognizes 85%, 84.5% that this is a vehicle, and it also classifies it as a class of auto. So this is what the default classifier provided to us. Let's look at another example here. We're going to, in the earlier example, we classified this by providing the URL of the image. So this is an image that we find it somewhere on the internet, let's say, or in our internal network, and we pass it to the well, not the internal network, because Watson has to have access to it. So it'll be definitely a URL on the public network, and you pass it to the service endpoint, and it can classify that. Now, there are cases where you want to where you have the image local on your hard disk and you want to upload it and see how Watson classifies that image. So in this case, I'm going to use a bird image. So let's take a look at that bird image here. So I'm going to open the bird image here, and as you can see, it's a simple image of a bird, a couple of birds here. So this is my personal image. Watson hasn't seen this image before, so let's upload this and see what Watson will make out of this image. So as you remember from example before, we are going to use the same endpoint, v3 classify, passing our API key, but this time, instead of passing a URL at the end, we are going to use a post verb and pass the images file parameter and instruct cur to read it from my current directory. So it's going to essentially upload this image to Watson endpoint and invoke the service. So let's try that. As you can see, it's uploading the image, and here it comes back with a class of animal, 99% sure it's an animal, and it's 90.8% sure that it's a bird and it's a mammal, 52%, 53% sure that it's a mammal. So as you can see, this is an image it hadn't seen before. It's a pretty busy image, and there were like 2 birds in it, and it still managed to detect what animal it is. Now, in the same in a similar way, there's another endpoint which is used to detect faces. And in this case, we're going to invoke the endpoint called detect faces. Let's take a quick look at what this image is. And I'm going to go to the browser and open up that image. And here's the image of a celebrity, Johnny Depp. So let's see if Watson would be able to detect this image. Let's copy this image URL into the image URL environment variable, and essentially everything is the same as before, except for instead of using classify, we are going to use the endpoint called detect faces. So the Watson service is trained with a number of the celebrity faces to detect. So first of all, it's going to come back with some general information about a person, so an age, min, max, with a certain t-score, and then it's going to provide the coordinates of where it detected the face in that image. So it provides the height and width of that rectangle, and also the left and top corner coordinates on that image. And it detects that the gender of the person is male, and in this case, because it's a celebrity, it 99.9% determines that it's Johnny Depp. So pretty amazing to see that it recognizes faces in that manner, and also is able to detect a particular celebrity in that way. So far we saw how the visual recognition service can be used to analyze any particular image and or maybe detect a face in an image. And these are based on the default classifiers that are available. Now, what if there are custom images that are by default not available, not trained in the default classifier, and we'd like to create our own custom classifier? So this is the section we're going to look at how to go about doing that. There are a set of guidelines on how to train the service on a particular classifier and the defined classes within it. In our demo case, what I have done, I've created 20 images per class, and I've a number of test images that are not a part of the 20 images that I have uploaded for the training purposes. So for each class, I've defined 4 classes and for 20 images for them. But the general guideline is you need about 150 to 200 of images per class, and apparently at 5,000 the return on the training diminishes, so it basically plateaus at 5,000. So generally don't use more than 5,000 images. What is our custom classifier? Superheroes. What else? We're going to be training some superheroes. And the classes that we have chosen for this demo is going to be a number of the well-known superheroes that we know: Superman, Batman, Batgirl, Joker, and Spider-Man. So these are the characters. We define them as the classes in our superheroes classifier. And the default classifier, as it is today, doesn't recognize these superheroes. So what I have done is created a quick page of all these images that I'm going to be loading just for demonstration purposes. So I have downloaded these images. Well, I've asked my teenage son to do that, to help me in that, so the credit goes to him. So, and he has created or found a number of these or variety of images of the characters. So as you can see, there are different kinds of the different expressions of those superheroes. And amazingly, by uploading these different characters, it manages to actually differentiate them after we train the system. So how do we train the system? It's absolutely trivial and very easy to do. All we need to do is post all these images that we have created. We'll zip up all those sets of 20 images, and we will pass it as a post invocation to the endpoint called classifiers right? So the classifiers endpoint is where we'll post all these images, and there are just two things to know. One is that this is the format of the parameter. You specify the name of the class in the beginning, underscore, and positive examples. So it means the zip file that you're uploading is going to have positive examples of that class. So in this case, batgirl underscore positive examples. We pass in the zip file for batgirl, similarly for Batman, Joker, Superman, and Spider-Man. And then there's also a name parameter, and this name parameter basically defines the name of the classifier that we have created. Now, of course, you can always go back and update the classifier by adding more training images to the existing classes that you have created. But in our example, in our case, we are going to just use these four or rather five zip files to train our system. Now I'll go ahead and select this command and go to my command line and post this in the command line where we will be creating the custom classifier called superheroes. And of course this is going to take a bit of a time because it's going to upload all of these images to the server. And then after the images are uploaded, it's going to start the training process. So as a response, we will see a JSON message come back that shows the status of our service in training mode, as you can see it here. And more importantly, this is the classifier ID that we have to keep track of to be able to use this for later on. I'm going to create a classifier ID environment variable that is set to the classifier ID that we just got back from the return of the service invocation. So how do we know when the service is ready? We're going to invoke the classifiers endpoint and pass in the classifier ID that we just got back with our API key and see what the status of that service is. So I'm going to run that again and see that our status is still showing in training mode. And this will take a few minutes, and after the training is over, we should be able to go back and use this classifier to invoke our services. Alright, now that we have given it a few minutes, let's go back and check and see if our service has been trained. And as you can see, the status of the training is shown as ready. It is completed. It just takes about a minute, given the number of images that I had and about 100 images of 5 different classes. It takes about a minute for it to create the classifier, the custom classifier. Now, the next step for me is going to be to validate whether the classes that we have created are actually working. So, to verify this, I'm going to use the post verb, use a few of the test cases that I have. So these are not images that I have uploaded. These are images that are downloaded, which are, some of them are not even close to the other images that I've created. And let's see how the service is going to do. So with the post, I'm going to pass in the images file property and pass in the file name that I want the service to classify. And then because I'm going to classify it against both the default and also the custom classifier that we created earlier, I'm going to pass in also parameters property, parameter to reference a JSON file that contains the parameters that I have set. So let's take a quick look at what that JSON file looks like. All I have there is a classifier IDs property that has an array, a JSON object that has an array that shows the superhero classifier that I have there, and also the default, which is called the default classifier. So in this scenario, I am going to use the classifier ID that we got. That's an old classifier ID, so let's quickly update that classifier ID so that we get the correct results back. So I'm going to change that and then add that classifier there. So now our parameter, superhero parameters JSON file contains the correct classifier ID, our custom classifier ID. And I'm going to pass in this image, so supermanross.png. So let's open up that file. So I'm going to open the Superman Ross PNG file, and as you can see, this image is none of the images we saw earlier in this set. So this is a completely different image, and it's amazingly not close to any of the other ones. So let's see how well the system does. I'm going to go back here and get a copy of this command. So I'm going to post that against the classify, passing in the API key, and in my superhero parameters JSON file I am passing already the classifier IDs. So let's go in and run this command and see what we are going to get. So this classified against the superheroes classifier and also the default classifier. See the name default. So with the default classifier, it classified it as the class of person, 94% sure it's a person. And if you look at our own custom classifier, which is the superheroes custom classifier, it determined that 98 point almost 9% that it's Superman, which is pretty nice. Given that there was very little similarity. So same thing, let's look at the Batman Arkham. So I'm going to open that file as well. So Batman Arkham City. So this image, as you can see, is not in any of the images we have here. So that character doesn't exist in any of these. So let's see how well our system is going to do against this. So let's select that and paste it here. And there we go. It's going to basically classify it against our own custom classifier called superheroes, and it determined that it's 97.1% Batman. And the more interesting comparison would be with between Batman and Batgirl, because as you can see the features are very close. There are a lot of similarities, and the system would I thought that it would have a lot of difficulty to actually distinguish between these features. So let's go and pick one of the cases where we have a Batgirl image. So let's see, Batgirl. So let's pick this one. So it is actually going to be an image that is a combination of actually Batgirl, or let's see. So we can probably use the other one here, Batgirl killing Joker. So let's see, open Batgirl killing Joker. So this is the image of Batgirl, and as again you can see, it's none of the images that we have here, and it's going to compare it against and not confuse it with the Batman image. So let's see how well our system is going to do comparing that image to Batman. And see, it's getting a little bit trickier. It is determining at 68% that this is Batgirl, which is still a pretty good accuracy because the images are very dark, very close to each other. The features are very similar, so it still manages to distinguish these features. And there's actually another one with a Joker face. If I have Spider-Man, well, anyway, so there are all these different examples here that we can go through and see how the service is basically doing. So this is an image of let's see, Batman and Batgirl together. So this is the image that we just asked the system to validate for us, or to classify for us. So let's open that image. So this is an image of both of them in the picture, and it still managed to classify them as 58% Batgirl and 68% Batman, which is again pretty interesting that it manages to find both of those in the image. So this is how you would be able to train your, as a recap, you pass in the sets of images per class, and you're able to train your system given a custom classifier ID, and then go back and test to validate whether your service actually worked or not. Okay, now that we're done with creating the custom classifier and working with it, let's say that we want to we're done with our demo and we want to delete that classifier. So this is pretty simple to do. We're going to just use the delete verb and again post against the classifier's endpoint, and use the classifier ID that we had created earlier. As a result of the custom classifier creation, we got the classifier ID back. So we're going to now delete our classifier using this delete post command, and as you can see, now our classifier is gone.